Okay, so before we start the new material, we're going to go over review from last time because we're pretty much just adding on to what we've already learned. Okay, so we're going to be combining aluminum's MCI and nitrite. So for aluminum, periodic table, aluminum is right over here. And for the pattern, you guys should have on your notes that it is +3. So Al 3+. Okay, for nitrite, nitrite is a polyatomic that we learned about last class. So we have our chart right here. Again, you don't need to memorize this. You only need to know how to use it for your assignments and whatnot. Nitrite is NO2 -1. Okay, I know there's a 2 here, but the 2 applies to how many oxygens there are. The charge is -1. Okay, so nitrite is -1. NO2 minus. Alright, so what we got to do is we have to balance out the positive and negative energy. Okay, +3 -1, so we need 3 of these in order to balance out the aluminum. And so the compound that we make is going to be AlNO2, but we put it in parentheses, so 3. Alright, so if we're going to write the entire balanced equation, it's very simple. We just take the information we have and we just add coefficients and whatnot. You only need 1 aluminum, so you can leave that alone. So it'll be plus, and you need 3 nitrites, and you make 1 of this. So this is going to be your balanced equation right here. Alright, any questions on this problem? Hopefully not too bad. We're going to keep doing the same thing today. The only thing is we're going to add on one more thing like I mentioned. Alright, so if there's no other questions, let's talk about the new information for today. So today, this is the title of our lecture, and I'm going to just talk about what the title is because that's going to tell us what we're learning. So IC is just short for ionic compounds, and then we have nomenclature. If you want to write down what this means, what that means is it's going to be naming. Alright, so we're going to be learning how to name these compounds today, these ionic compounds. So we're going to learn all the rules for naming these ionic compounds, and then we're going to do a couple practice, and that's pretty much it for today. So the actual hard work is not too bad. We've been doing it. We're just going to be adding on some naming. Okay, so let's talk about some of the rules for naming these ionic compounds. The first rule is very simple. You always write the cation first, and then you do the anion second. Okay, so cation first, anion second. Okay, second rule for the name, it's very easy. The cation, the first name, it's going to keep its name. We'll talk about what that means in a second, but the cation keeps its name. Okay, so all you need to do is find the name of the cation, and you just write it down. Okay, you don't change anything about it, just copy it down exactly the way it is. And then the third rule is the one that's a little bit, it's going to require a little bit more thinking. It's going to be about the anion. And the anion, the name will change depending on where it's from. Okay? So if the anion is from the periodic table, okay, so if it's an MCI, if you got to get it from the periodic table, you change the ending to IDE. And I'll talk about what that means in a sec, but whatever the anion is, you change the ending to IDE only if it's from the periodic table. But if it's from the polyatomic chart, okay, you do not change the name, so no change. Okay, so let's name the ionic compound that we wrote for our warm-up. So let's start with the cation. The cation is Al. Okay, and then Al, if you look on the periodic table, is aluminum. So the first part of the name is aluminum. Okay. The second part of the name, this is nitrite. And if you remember, we got it from the chart down here. Okay, so since nitrite came from the chart, we do not change the name. There's no change in the name. So the second part of the name is just nitrite. And that's it. So the name of our ionic compound is aluminum nitrite. Easy peasy. So this is what we call the name. And the thing that we've been doing, this is what we call the chemical formula. And that's pretty much what you'll be doing today. You'll be writing down the formula and the name for these ionic compounds. And then I think 2 classes from now, we'll do our first lab where you'll be, God bless you, where you actually make these ionic compounds, we'll figure out the formula and the names. Okay, that's what we're kind of building up to. So if you guys scroll down a little bit in the notes, you'll see these rules. I have the rules written out for you, so if you ever lose your notes or you just want to pull it up real quick, you guys can look, and the rules will be right here for you. In terms of the IDE, nitrogen turns into nitride, oxygen turns into oxide, F turns into fluoride, so on and so forth. This list is right here for you guys. Okay. All right, but let's have you guys try 2 and 3 on your own. You'll have to use the periodic table and your polyatomic chart. So write the formula and see if you can get the name as well. I'll give you guys about 3-4 minutes to do that, and then we'll go over them, and then I'll teach you guys the last rule, and then we'll be done. All right, so I'm not going to go to the periodic table just because we've done that quite a bit for the MCI. Should be pretty easy. So lithium's MCI, everybody get Li+? Yes. Yes? Okay. And chlorine is Cl-. So in terms of the actual formula, it's pretty easy. Li+ and Cl- are going to make LiCl. So that's our formula. I don't. Okay, everybody go to the formula? Okay. Let's do the name now. So the name is the new thing. Remember, the cation, the positive one, we don't change it. So Li is lithium, so the name is, the first part of the name is lithium. Cl, we got to figure out where does it come from. Does it come from the periodic table or from the chart? And hopefully, since it's MCI, you guys can identify that it comes from the periodic table. So that means we have to change the ending to IDE. So we're going to change chlorine to chloride. Okay, so the name of this compound is lithium chloride. If you got that, great job. That's pretty much naming. It doesn't get harder than that.
So you just change it to IgE for the periodic?
Correct, yeah.
And if not, you'll be the same.
Correct. All right, let's move on to number 3. Ammonium, if you look at the polyatomic chart, this is NH4+. Okay, oxygen, MCI is 2-. So in order to balance this out, we need 2 ammoniums to balance out the 1 oxygen. So if we write the formula, it's going to be NH4 with parentheses, 2, and O. For the name, again, cation, keep it the same. It's ammonium, so we write ammonium. And then the O, this is from the periodic table, so it's oxygen. It turns into oxide. Okay, if you wrote oxide, that's totally fine. You get the general idea. But if you want the actual correct names, the thing that your Canvas quizzes will take, you can scroll up here, and then it'll have all of the anion with the names changed at the end. Okay. Alrighty. Any questions on that? Easy peasy? Yeah. Okay, nice. Okay, we're gonna add on to this. There's one last naming rule, and it's basically a third part to the name that applies to some elements. So I'm going to pull up my periodic table. You guys can take a look at yours. And for the next example, I want you guys to, real quick, write the formula for the ionic compound that is formed by Fe4+, and we'll do sulfate. So Fe4+ and sulfate. See if you guys can write the formula. You guys can't do the name yet. I'll talk about the name in a second. But just write the formula for now, and then we'll go over it, and I'll teach you guys how to do the name. We'll do one more example, and we'll be done. Okay, guys, let's do the formula first, and then I'll show you guys how to do the new name. So we're doing Fe4+ and sulfate. Sulfate comes from the polyatomic chart, so hopefully you guys saw this is SO4 2-. Okay, so pretty simple. We have Fe4+ and SO4 2-. So we're gonna need 2 sulfates in order to balance out 1 Fe4+. Okay, so if we put them together, we'll have Fe and then parentheses SO4 2. Okay, so that is going to be our formula. Okay, so we're going to do the naming for this, and most of the naming rules are going to be exactly the same. Okay, so Fe, if you look right here, is iron, right? So we're going to write iron. And then the anion is sulfate. This is from the chart, so we can just write sulfate. Okay, so most of the naming is exactly the same. Okay, the only new thing that you guys need to be aware about is depending on where the cation is, it's going to require us to add one more thing. So if the cation is right here, so this section right here in the middle, or it's on the very bottom of the periodic table, okay, what we have to do is we need to add something in between the cation name and the anion name. Okay, so the conditions are if the cation is in groups 3 through 12. So this is that weird section again, groups 3 through 12 in the middle or the bottom. Okay, so if it is in groups 3 through 12 or on the very bottom, so for example, right now we're looking at iron, or if you have something like tungsten, or if you have something like uranium down there, so any element that's in the middle or at the bottom, the thing that we need to add is we need to add the charge, okay, in between the names. Okay, so we have to add the charge. So whether it's +1, +2, +3, so on and so forth, we just need to add that in between. Okay, and I'm going to show you guys how to do that. Okay, so just to repeat myself, if an element is in the middle, so groups 3 through 12, or at the very bottom, we have to add the charge in between the name. Okay, and there's a very specific format. The way that you need to add it is you're going to add parentheses in between, and you are going to add the charge, but it has to be in Roman numerals. Okay, I know it's really specific, but it's just the way that chemists do it. Okay, so I'll give you guys what the Roman numerals are that we're going to be using are. So if it's 1, it's just a line. If it's 2, you put 2 lines. If it's 3, you put 3 lines. If it's 4, you do IV. And if it's 5, it's V. And we won't do anything higher than that. Okay, so since it's iron 4, we would do iron parentheses IV parentheses sulfate, and that's going to be the name. All right, and that's pretty much all the naming. Now you know how to name pretty much all the ionic compounds. Okay, so for the weird ones in the middle, we just need to add the charge in parentheses, Roman numerals in the middle. Yeah.
Does it always go in the middle?
Yes, always goes in the middle. So you only have this parentheses for the cation. Everything here is always going to be a positive ion. Yeah. Yeah, you'll never have a negative ion from here, so yeah, you'll always be positive. All right, I'm going to have you guys try one on your own. Okay, so let's do, let me erase this real quick. And then we're going to add number 5. So I want you guys to try, let's do cobalt 2+, and let's have you combine that with, let's do bromines MCI, so BR's MCI. Okay, so see if you can write the formula and the name of this compound. So we got CO2 plus BR's MCI. If you take a look, BR is right here. It's in the -1 column, so BR's MCI is -1. Okay, so it should be pretty simple to balance this out. You're going to need 2 BRs in order to balance out the CO, so it'll be CO BR2. Oops, lowercase. Okay, everybody good with the formula? Okay. All right, name. CO is right here in the middle, so it will be cobalt. But since it's in the middle of the periodic table, we got to add the parentheses. The charge is +2, so cobalt 2. And then right here is going to be bromide. All right, so that is going to be the name of this compound. Again, if it's in the middle, just got to add the charge in parentheses in the middle. All right, so I did lie to you. There is one more problem we need to go over. So I apologize for that. Okay, and for this last one right here, we're going to be working backwards. I'm going to give you guys the formula, and you need to figure out what ions it's made out of and figure out the name. Okay. So let's have you guys try one, or let's go through it together, and then we'll be all done. Okay, so we're going to look at PT2 O. A PT2O. So take about a minute. See if you can write the name of this this compound first, and then I'll show you guys how to write the formula for the equation for it, and then we'll be all done. So write the name for PT2O. All right, so for the name, pretty simple. PT is right over here. It's platinum, so we're going to write platinum. Okay, but since it's in the middle of the periodic table, we need to add parentheses. So we'll do that in a second. And then O is going to be oxygen. So we got to change the ending to oxide. Okay, so oxide. So that part should have been pretty easy. Just the name of the two. Okay, the tricky one is what do we put in the middle? Now, if you guys remember, in the middle, in the parentheses, this is where we put the charge. Okay, so we got to figure out what platinum is. Is platinum +1, +2, so on and so forth. So we need to look at the formula. Now, if you look, platinum has combined with oxygen, right? And if you look at oxygen, oxygen is in the -2 column. That means this oxygen is -2. And there are 2 platinums that are balancing out the oxygen. So if we kind of separate this out, it basically looks like this. There are 2 platinums balancing out 1 oxygen, and the oxygen is -2. So what does each platinum have to be to balance out the oxygen? 1. So that means each of the platinum is +1. So that means inside the parentheses, we put platinum 1 oxide, and that's going to be the name.
That's only for when they're in this section.
That's when they're in the middle section. Okay, so just to repeat myself, to find the thing in the parentheses, we just kind of have to look at what platinum has combined with. Platinum has combined to oxygen. Oxygen is -2. There are 2 platinums balancing out -2. That means each platinum has to be +1, and that's what goes inside of the parentheses. So platinum 1 oxide. All right, so for the equation, pretty simple. It's made out of PT plus, and there's 2 of them, combining with 2 or 1 oxygen, which is -2, and that makes PT2O. So this right here is going to be your equation.